Hello students, in this lecture we will see star delta transformation. What do you mean by star network, delta network, and why such transformation is required, how you will derive the formula for the star and delta resistances and associated numerical on that. Let's say the numerical is find an equivalent resistance between A and B. Now if you observe this numerical carefully, these three resistances are in series. Also these three resistances are in series. So between A and B, I will have two branches which are in parallel. In one arm, I will have 4.5 plus 4 plus 4.5. So that turns around to be 13 ohm. And in another arm, I will have resistance is 7.5 plus 3 plus 7.5. So that is 18 ohm. So RAB is nothing but 13 parallel with 18. And that turns out to be 7.548 ohm. So this is quite easy. Now if you talk about numerical 2, compared to this numerical, two resistances are added over here. Now can you able to find out the resistance between A and B using series parallel combination technique or reduction technique? No, because no two resistances are in series, neither they are in parallel. Then here we have to go for star delta transformation. Now what do you mean by delta connection? Delta means three resistances arranged in a closed loop manner. Observe this circuit diagram carefully. These three resistances are connected in a closed loop manner across these three ends. So they are forming one delta network. Here also you can find one delta network. What about star network? So star network will have one common point and the three resistors will be connected from these three ends towards the other three vertices. So at this point you can see here 4.5, 3 and 4 they are connected. Over here also you can see a star connection. So 4 star connection you can easily find. Now which conversion has to be done so that we can simplify the thing, or is it necessary to do the transformation over here? Let's say if I able to convert this network into a star network, then what I will have? I will have terminal A as it is over here, rather I will mark over here, and from these three ends I will have three resistances towards this one. Instead of delta, if I place a star over here, even instead of this delta, if I place a star network over here and remove these delta resistances, then I can have again the series, parallel and again the series connection, and I can solve this. We will solve this numerical in the next lecture, but before that the required formula for the transformation will derive over here, and then we will see which transformation is to be done when and how to simplify this. So when the circuit cannot be simplified by normal series parallel reduction technique, we have to use star delta transformation. So this is a delta connection where three resistances RA, RB and RC, they are connected in a closed loop. Delta is also known as mesh connection. In the second diagram, R1, R2 and R3, they are connected in star connection. Star is also known as Y connection. You can represent Y like this one also. So these two networks can be replaced by each other if they are electrical equivalents of each other. Now what do you mean by electrical equivalence? Let's say from the first network, if you calculate the resistance between 1 and 2, and I am denoting that resistance as R12 over here. If you calculate the resistance between 1 and 2 over here, then these two resistances of these two networks should be same. Not only that, if you calculate the resistance between 2 and 3, I am denoting that resistance as R23 for the delta network, and for the star network again it is R23. These two resistances should be again, let's say if you calculate the resistance between 3 and 1 and 3 and 1 over here, then these R31 should be again same. So if you measure the resistance between any pair of terminals, it should remain same in both the network. Then only you can say they are electrical equivalents of each other. And we will use this electrical equivalence for deriving the necessary formula in the transformation. So we will proceed for the derivation, and here is the first part of the derivation where you will be converting the delta network into star. What do you mean by this? You know RA, RB, RC. Their values are known to you, and you are calculating equivalent resistance R1, R2 and R3. So we will proceed for the derivation. On the left hand side we will write down the equivalent resistance for the delta network, and here we will write down the equivalent resistance in the star network. Now the first point, if you calculate the resistance between terminal 1 and 2 for the delta network, between 1 and 2. Then that means a third terminal we don't consider, and you can have RB and RA in series. So that will eliminate terminal number 3. Not only that, these two resistances are in series and RC will be in parallel. Why? Because you are measuring the resistance between 1 and 2. So that will give a formula as that RA plus RB, they are in series and this combination is in parallel with RC. So I will solve this thing and I will have RA/RB multiplied with RC divided by RA plus RB plus RC. So I have evaluated R12 from delta network. Now I have to calculate R12 from the star network. So R12 from the star network can be calculated as, now the third resistance R3, the third terminal is left open, rather one end of R3 is left open. So if you try to calculate the resistance between 1 and 2, R1 and R2, they will come in series in the star network. So that is the formula for R12. Now these two circuits are electrical equivalent. So I can equate R12 of these two. That means I will get R1 plus R2. I am writing this first and this should be equal to RA plus RB into RC divided by RA plus RB plus RC. And this is my equation number 1. Now I will equate the resistances for the other pair. So let's say if you are measuring the resistance between 2 and 3. So R23 will be RA parallel is series combination of RB and RC. So here I am writing RB plus RC, they are in series and that connection is in parallel with RA. So if you solve this thing, what you will get, RB plus RC into RA divided by RA plus RB plus RC. Now here R23 can be calculated from the star network. It is nothing but R2 plus R3. Now equate R23. So I will get R2 plus R3 which is equal to RB plus RC into RA divided by RA plus RB plus RC. And this is my equation number 2. Similarly, I will obtain the third equation by calculating the resistance between 3 and 1. So for 3 and 1, what I will have, RB in parallel with series combination of RA and RC. So I am writing over here RA and RC, they are in series and that is in parallel with RB. So when you simplify this thing, you will get product, that is RA plus RC into RB divided by RA plus RB plus RC. For the star network, R31 turns out to be R3 plus R1 because one end of R2 is left open, so that will not matter. So that I am writing over here R3 plus R1 is nothing but RA plus RC into RB divided by RA plus RB plus RC. So you have formed 3 equations. And your aim is to calculate R1, R2, R3 in terms of RA, RB, RC. This is my equation number 3. Now how to proceed ahead? Now how to obtain R1, R2 and R3? So let's say if I subtract equation 2 from 1, the left hand side will become R2 will get cancelled and I will get R1 minus R3. And for equation number 3 I have R3 plus R1. So if I add R3 plus R1 with this one, R3 will get cancelled and I will get the value of 2R1 and I can find out the value of R1. So let us execute this thing. So you have to subtract equation 2 from 1 and then you have to add that with equation number 3. So I will get R1 minus R3 and the denominator is RA plus RB plus RC and the numerator is RA/RC plus RB/RC. This is from equation 1 and you are subtracting, so here I will have RB/RA minus RC/RA and this will get cancelled. I will call this as equation. And now you are adding this with equation 3. So let us add these two things. So the left hand side will become 2R1. The denominator will be same, that is RA plus RB plus RC. And when trying to add the numerator, what will happen? RA, RB will be over here. Even RC, RB will be there. Here I will have RB, RC and I will have RB into minus RB into R. So this will get cancelled and I will have twice RB, RC divided by RA plus RB plus RC. So again this 2 will get cancelled and I will have the formula of R1. And the formula of R1 is RB into RC divided by RA plus RB plus RC. So you have derived the formula of one of the resistance in the star network, that is R1. Similarly, you can write down the formula of R2 and R3. But how that? Keep this formula in the circuit and we'll see what is the inference. So R1 is RB into RC divided by RA plus RB plus RC. So that I will write over here. So the formula of R1 is, just now we have derived, and it turns out to be RB into RC divided by R1 plus R2 plus R3. So what it tells, R1, it is connected to terminal 1. To terminal 1 in the delta network, you have RB and RC. So their product is appearing in the numerator, while the denominator is addition of all the 3 resistances of the delta network. Similarly, you can write down the formula of R2. R2 can be written as, first of all, you can write down the denominator. Denominator is R1 plus R2 plus R3. And the numerator, how to write down numerator? R2 is connected to terminal 2. So to terminal 2 you have RA and RC. So their product will appear over here. For R3, what will happen? The denominator will remain same, and that is addition at R1 plus R2 plus R3. R3 is connected to terminal 3. To terminal 3 you have RA and RB. So their product will appear. So we have completed the first part of the derivation where we have converted delta to star. Now how to remember this? Remember, when you are converting delta to star, the denominator remains same. So what do you mean by denominator remains same? Denominator is addition of all the 3 resistances of delta. So delta to star, denominator remains same, and that is addition of all the 3 resistances of delta. While the numerator is product of 2 resistances connected to that terminal. What do you mean by this? R1 is connected to 1, RB and RC, their product will appear. R3 is connected to 3, R3 is connected to 3. So to 3 you have RA and RB, their product will appear. R2 you will have RA and RC, their product will appear over. Okay. So you have completed first part of the derivation where you have converted delta to star network. I am writing this formula again in the next slide. So here the formula of R1 is connected to terminal 1. So RB into RC will be the numerator, and denominator is RA plus RB plus RC. For R3 is connected to terminal 3. RB into RA, or rather RA into RB will be the numerator, and the denominator is RA plus RB plus RC. R2, RA and RC, they are connected. So here I will have RA into RC divided by RA plus RB plus RC. Now we proceed for the second part of the derivation, where if you know R1, R2, R3 and you have to calculate RA, RB and RC, then how to proceed? So let us calculate R1 into R2 plus R2 into R3 plus R3 into R1. We have already derived the formulas for R1, R2, R3, and we are taking help of that one for further derivation. So my denominator will be, when you are calculating this big thing, the denominator is same, so that will simplify the thing, and I will have denominator as RA plus RB plus RC the whole square. And what will be the numerator? When you are calculating R1 into R2, so if you see the numerator, here I will have RA, RB, RC square. So this I have calculated, plus R2 into R3. So I will have RA square, RB into RC. And then when you are calculating R3 into R1, that means I will have RA, RB square into RC. So I have calculated this left hand side. You have to remember this thing. Addition of product of 2 resistances taken at a time. Now what is common from the numerator? Observe carefully. You will have RA, RB, RC common, and what remains inside bracket? RC plus RA plus RB. And what is there in the denominator? RA plus RB plus RC the whole square. So one of the bracket will get cancelled. So this will give me a formula as RA into RB into RC divided by RA plus RB plus RC. And what is the left hand side? Left hand side is R1 R2 plus R2 R3 plus R3 R1. Now if you combine, let's say RA RB, these terms over here, Now what is RA into RB? So see over here. So this is nothing but R3 into RC. So I can write down this as R3 into RC. Why you are combining these terms? Let's say if you combine RA into RC, these terms, RA into RC divided by RA plus RB plus RC, then that is nothing but R2 into RB. So that I will write over here, R2 into RB. And let's say if you combine RB into RC, RB into RC divided by RA plus RB plus RC, then RA is left alone and RA, and this is the formula for R1, correct? Now you can have the formula for RA, RB and RC. So how to write down the formula of RA? So RA will be, R1 you have to transfer it over here. So numerator will remain same, that is R1, R2, R2, R3 and R3, R1 divided by R1. How to write down the formula of RB? RB will be, the numerator is R1, R2, R2, R3, R3, R1 divided by R2, and the third one is for RC. So RC can be written as R1, R2, R2, R3 and R3, R1 divided by R3. So one thing is clear, that when you convert star to delta, numerator remains same, and numerator is addition of product of two resistances taken at a time. And what about the denominator? So that we have to see. Now let's say if you are talking about the formula of RA, the denominator is R1. Why the denominator is R1? RA is connected between 2 and 3. So from the star network you don't consider 2 and 3. R1 is over here, so that R1 will come over here. So denominator is a resistance which is not connected to that terminal, which is not connected to those terminals. So this is how you can remember the formula. Delta to star, denominator remains same. Star to delta, numerator same, remains same. Delta to star, denominator remains same, and it is addition of all the three resistances. Star to delta, numerator remains same, and it is addition of product of two resistances taken at a time. So we will proceed ahead for the numerical. Now convert the star circuit into equivalent delta circuit. So we have to convert star to delta. Star to delta, so how we have to convert? So I will give you simple way. So first of all, you will have three terminals A, B and C. So when you are converting star to delta, you will form a network like this one. Star to delta, the common point gets vanished. Now you write down these 2, 6, 8 over here and you calculate numerator. Star to delta means numerator remains same. So first you take these two values, so you will have 12, their product, 6 into 8, 48 and then 8 into 2, 60. So you add them. So this turns out to be 76. So everywhere you write down numerator as 76. Okay. Now you have to write down denominator. Now 8 ohm is connected to C. So that 8 ohm will be the denominator over here, which is connected for the resistor which is connected between A and B. 6 ohm is connected to B. So this 6 ohm will be denominator will be over here. And 2 ohm is connected to A. So 2 ohm will be denominator over here. So you will have the resistance is as 38 ohm. Here you will have 12.67 ohm. And here you will have resistance as 9.5 ohm. So this is how we convert star to delta. First you calculate numerator, write down that numerator everywhere and then divide by the resistance which is not connected to that. The second numerical is convert the delta network into equivalent Y network. So delta to star. So delta to star means denominator remains same. So first of all I will mount the network over here. So I will have A, B and C, these extreme points as it is. And I will have a common terminal over here. Remember, when you convert delta to star, a common point will get introduced. Star to delta, the common point will get vanished. And from this common point, you will have three resistances like this one. Now, denominator remains same. So, everywhere you have to write down the denominator. Denominator is addition of these three resistances. So, 10, 25 and 15. So, the denominator is 50. So, denominator is 50 everywhere. And now we have to talk about the numerator. For the resistance which is connected to terminal A, the numerator will be product of these two resistances. So product is 250 over here. So the resistance is 5. For the resistance which is connected to B, B is over here. And to B you have 25 and 15. So their product will appear over here. So 25 into 15 divided by 50. So this will give me 7.5 ohm. So to terminal C, 10 and 15, these two resistances are connected. So their product will appear over here. 10 into 50. So this will give me the value of 3. So remember this thing, I am again repeating, when you convert delta to star, the denominator remains same and it is addition of all the 3 resistances. Numerator is product of 2 resistances connected to delta. When you convert star to delta, the numerator remains same. Numerator is addition of product of 2 resistances taken at a time. And the denominator is resistance which is not connected to that terminal. This will get more simplified as you solve more numericals on this one. Thank you.